So 1 plus x to the power x plus x to the power 1 plus 1 by x. Yeah, so how can we solve now? So this is like our second condition, right? So you have to consider this to be u and this term to be v, correct? So our equation will be y is equal to u plus v, correct? And we have to differentiate. So dy by dx is equal to du by dx plus dv by dx, correct? So we have to differentiate u term separately, v term separately, then add it together, correct? So my u is x plus 1 by x to the power x. Okay, now apply log on both sides. So log u is equal to, so when you apply log, the exponents becomes, one second, so x into log of the term, correct? So the next step what you will do, so you have to apply the properties of log, so you can expand it. Log u is equal to x into, so how can you expand this? It is log of x plus log of 1 by x, correct? So either you, if you want to expand, you can expand, or else if you want to apply the differentiation directly to this, you can do the same. So will not expand, it will be complicated. We will keep it as it is. So here you can apply product rule for two terms. If you expand it, you have to do the product rule two times, correct? Yeah, so let's differentiate on both sides. So differentiation of log u is 1 by u du by dx, and this you have to solve with product rule. So according to product rule, first into differentiation of second, this is my first function, this is my second function. So first into differentiation of second plus second into differentiation of first. So first function, differentiation of second, so differentiation of this is 1 by 1 by x, correct? And you can differentiate, so, and differentiation of this term, chain rule. So differentiation of x is 1 and differentiation of 1 by x is minus 1 by x square, correct? Plus second into differentiation of first. So second term is log x plus 1 by x, and differentiation of first. Differentiation of first is x. Differentiation of x is 1. So I'll not write it. Okay, then later what you can do, 1 by u du by dx. Yeah, so let's try to simplify this. So what I will do is I'll multiply this x inside. Okay, so what I will get, x minus 1 by x divided by x plus 1 by x, correct? Plus log x plus 1 by x, correct? So how can we further simplify this? Just try to take the LCM and try to eliminate the denominator. So if I take LCM there, so it will be x square minus 1, here it will be x square plus 1, and see, divided by x, and here also divided by x in the numerator term and denominator term. I can just cancel it, right? So I am not going to write it, I will write it directly. Okay, is it fine? So you understood, no, how I got this term from this?
Yeah, sir.
Okay, plus log x plus 1 by x. Okay, so now 1 by u du by dx. Question number 5.566. Okay, so let's keep it in that form itself. Yeah. Now what you'll do is, u is there, right? You send it to other side, du by dx. So what is u term in our question? It is x plus 1 by x to the power x, right? So here I will write it again. So x plus 1 by x to the power x, then whatever term we had got here, same term you have to write again. Okay, this term itself you have to write it again. So copy, yeah. So this is our du by dx. Okay, similarly you have to do dv by dx. Okay, so here v term is what now? V term is x to the power 1 plus x to the power 1 plus 1 by x, correct? So here also apply log on both sides. Log v 1 by x log x, correct? Then what we have to do? Differentiate on both sides. So just differentiate. So 1 by v log v 1 by v dv by dx, dv by dx is equal to, yeah, here what you have to do? You have to do product rule, correct? So first into let this be my first function, this be my second function. Okay, so first into differentiation of second. So which is the first function? Here 1 plus 1 by x. First differentiation of second, it is 1 by x plus second function log x, differentiation of this function. Differentiation of 1 is 0 and differentiation of 1 by x is minus 1 by x square, correct? So now let's just simplify it. Yeah, we can just simplify. So how can we simplify? So I'll just multiply these two. So what will be there? 1 by x plus 1 by x square plus, let it be minus 1 by x square into log x, correct? So I'll make the denominator same. Okay, so what happens? I can write, instead of this term I can directly write x plus 1 minus log x divided by x square. So did you understand how did I write this? You understood the steps, right? What did I do?
Yes, sir.
So this was there, right? I just added it. So this is what you will get. Okay, so then, so therefore dv by dx, so v is there, no? You have to send it to that side, to the other side, right hand side. So what you will get? Dv by dx is equal to, so what was our v was x to the power 1 plus 1 by x, correct, into the whole term, whatever we got just right now. So x plus 1 minus log x by x square, correct. So now we know what is v, we know what is u, correct. So dy by dx is equal to sum of those two terms, correct. So du by dx, what answer we got? X to the power x. So we got this answer, right? X to the, not x to the power x, it is x plus 1 by 1 1 by x to the power x into this term x square minus 1 x square divided by x square plus 1 plus log x plus 1 by x. Plus this term dv by dx, whatever we got above, correct. Yeah. So this is our answer. So if you want, you can verify it in your textbook. So in textbook also same answer is there, it matches. So you understood, no, how to solve this? Okay, so in last class you had asked me one doubt, right? If you have like this y to the power x, why you can't apply this rule, uh, dy by dx x to the power n, nx to the power n minus 1, why you can't apply this rule, correct. So here this rule is applicable when x to the power some constant, so this can be only number, correct. Here variable to the power variable is there, so this rule is not applicable, but while writing the answer you get some form of this rule, correct. We had seen that, correct, plus some other term you will get. Okay, so if you apply directly this rule, what happens? Whatever answer you will get, no, that will be wrong answer, because this is not a constant, it is a variable. Understood? So what is the suitable method for this? So we have to apply log on both sides. Okay, so don't write the answer like this, x y to the power x minus 1. This is not suitable. Why? Because this x is not a constant. Understood? Who asked me that doubt actually? Bhumi or Swati? You got that answer, right?
Sir, I didn't ask that.
Okay. Yeah, let it be.
So even I didn't ask that.
Then, yeah. Okay, no problem. Yeah. So let's continue. Question number 7 is similar. So question number 7, can you do it on your own? Which rule you have?
Yeah, sir.
U plus V. Okay. Question number 7. So homework for you. Question number 8. Okay. Let's solve question number 8. It is little bit different. Okay. So in question number 8, see, it is also same thing, but okay, let's solve. See here, in question number 8, there is one difference. There is some expression raised to some power, plus there is some expression that is not raised to some power, correct. If you have some expression in this form, what you have to do? you have to apply the same rule, which is y is equal to u plus v. Okay, no difference at all. So if you find any 1 plus here, you can apply the same rule, no problem. So we'll solve using the same rule again. So y is equal to u plus v implies dy by dx is equal to du by dx plus dv by dx. Correct. So let u be sin x to the power x. Yeah. So apply log on both sides. Log u. Here the powers will be multiples. Log sin x. Yeah. After that product. After that differentiate on both sides. So differentiation of log u is 1 by u du by dx. Here you have to apply product rule. So first function into differentiation of second function, that is 1 by sin x. Then differentiation of sin x is cos x into cos x plus second into differentiation of first. Second function is this, right? So log sin x, differentiation of x is 1, so I will not write it. Okay, so later what you can do, du by dx is equal to, here cos by sin x you can write it as cot x. Okay, let's write it as cot x. So u, take it to the side. So what is u? It is sin x to the power x, correct, into this term, write it as it is x. Here cos x by sin x will be cot x, and yeah, log sin x as it is. Yeah. So next we'll find dv by dx. Okay, so first what is v? V is equal to sin inverse root x, right? Is it correct? Yes, sin inverse root x. So what is formula for differentiation of sin inverse x? It is 1 by root of 1 minus x square, right? In place of x, what is there? Root x whole square. So I can just write it as 1 minus x into, what is differentiation of this root x? It is minus 1 by root x, correct? Minus 1 by 2 root x. Is it right? X to the power half. So it will be half into x to the power 1 minus half is minus half. Yeah, it's correct. 1 by 2 root x, it is not minus. Yeah, now it's proper. So next step what you have to do, you can add those. So now I can further simplify this. See here, root a into root b, I can write it as root ab, correct? The same logic will be using here also. So here I can write as 1 by 2 root x into 1 minus x. You can write it in this way. Yeah. So then next step what you can do, you can multiply this within it, correct? So it will be 1 by 2 root of x minus x square. Okay, so next dy by dx is equal to du by dx plus dv by dx. So what is du by dx? Sin x to the power x, sin x to the power x, then x cot x plus log sin x. Plus, right? Plus, here whatever answer we got here, 1 by, is it 1 by, yeah, correct, 1 by 2 root x minus x square. Okay, let me check the answer. Yes, it's correct. Yeah, so this is how you solve. So this is not that much difficult. So you understood this, right?
Yeah, sir.
Okay then. So question number 9. Question number 9 and question number 10. Question number 11. So I'll see which is difficult in this. Question number 9, I think you can do. It's not that much difficult. Question number 9 is okay. Question number 10. Question number 11. Yeah. So let's solve question number. See, question number 9, I will give you a hint. Question number 9 is easy actually. Okay, we'll solve question number 9 now. Question number 9 is y is equal to x to the power sin x plus sin x to the power cos x. Yeah. Now, how can we solve this? You have to use u plus v. Correct. So now dy by dx should be equal to du by dx plus dv by dx. Okay, so I have assumed y is equal to u plus v. So u is equal to x to the power sin x and v is equal to sin x to the power cos x. Yeah. So now let u is equal to x to the power sin x. Apply log on both sides. Log u is equal to, here sin x will be as multiple, correct? So log x. Then what you have to do? Product rule. So 1 by u du by dx, sin x first function into differentiation of second, sin x by x plus second into differentiation of first. So log x as it is, differentiation of sin x is cos x, correct? Then du by dx is equal to, so u will become, u is x to the power sin x. So x to the power sin x into sin x by x sin x by x plus log x cos x. Okay, so this is du by dx. Now similarly we have to do for dv by dx. So here v is equal to sin x to the power cos x. Apply log on both sides. So log v is equal to, the power becomes multiple, cos x log sin x. Yeah. So now what we can do? 1 by v, differentiate on both sides. Differentiation of cos x, first into differentiation of second plus second into differentiation of first. Okay, product rule. So cos x is first, differentiation of second. Differentiation of log sin x is 1 by sin x. Differentiation of sin x is cos x, plus second into differentiation of first. So log sin x as it is, differentiation of first. What is differentiation of cos x? It is minus sin x. Yeah. Okay. So after that, what we'll do, we'll just simplify it. Question number 9, right? Yeah. So this can be written as cot x. See, this can be written as cot x, correct? And yeah. So dv by dx, so what is v? I'll send it to that side. So v is sin x to the power cos x, right? Into this term. So here, this I will write it as cot x. Cot x into cos x minus this minus sign. Sin x, sin x I'm writing it first, into log sin x. Okay, so we have dv by dx, we have du by dx. Okay, so dy by dx is equal to, so whatever answer you got, just write it together. So you'll get the answer. So it will be dy by dx is equal to, so x to the power sin x into sin x by x plus log x into cos x. So sin, it's not sin, yeah, x to the power sin x sin x by x plus log x cos x plus dv by dx term, correct? So dv by dx is this term. Okay, so that will copy here, and yeah, so this much is your answer. If you want, you can check the textbook. So in the textbook also there is the same answer. Yeah. So understood, right, how to solve this problem? So the only difficulty is it's not in differentiating. So if you differentiate properly, you will get the answer. But the difficulty is in solving it, rearranging it. Yeah. Question number 10. How can you solve it? U plus V, right? So here you can see this is little bit difficult, what I feel. So this is the question. X square plus 1 divided by x square minus 1. Here. How can you solve this question? Y is equal to. So assume this term to be u and assume this term to be v. So you have to apply log on both sides for this term. This term is optional. If you want, you can do it with applying log on both sides. If you don't want, you can use quotient rule. So I suggest using log on both sides. That only. Why? Because your problem will be easier while solving it. So will you try it? Should I solve this? This is little bit difficult. Why? Because here see power is there, x cos x, correct? X cos x and log x will be there. Here you have to apply product rule. See, there are three terms. For three terms you have to do the product rule. So should I solve this, or you'll give a try for it? So will you try this problem? Should I solve? It's little difficult, not that much difficult.
So can we try?
Yeah, so you try it. If you don't get the answer, just let me know in the next class. I'll do it. Okay.
Okay, sir.
Yeah. So next, let's move to question number 11. So I'll do question number 11 now. So question number 11 is y is equal to x cos x to the power x plus x sin x to the power 1 by x. Yeah. So now, so this also you have to solve with this method itself, u plus v. Okay. So now what we have to do? First, dy by dx is equal to du by dx plus dv by dx. Yeah. So next, u is equal to our first term, x cos x to the power x. Yeah. So apply log on both sides. So here x into log of x cos x plus nothing, no plus here. Okay, now next step, what you have to do? Differentiate on both sides. So 1 by u du by dx. Here, let this be my first function, this be my second function. So first function into differentiation of second function. So differentiation of second function is 1 by x cos x, then differentiation of this term, inside term. So how will you differentiate that? Again product rule. So first into differentiation of second. So cos x is minus sin x plus second into differentiation of first. So cos x as it is, differentiation of x is 1. So cos x. Okay. Plus second into differentiation of first. So second function as it is, log x cos x. So what is differentiation of first? First term is x, right? Differentiation of x is 1. So I will not write it. Yeah. So you got answer in this form, correct? So now what is remaining? We have to simplify. So how can we simplify this? So 1 by u du by dx, let it be as it is. Yeah. So here I can cancel these two, right? One thing I can cancel those two. Yeah. Then next thing what I can do? Yeah. So here cos x is there, correct? So cos x I will divide it by both term. So what will happen? Cos x by cos x is 1 minus here sin x by cos x will be tan x, correct? X tan x. Then yeah, so this term is simplified. Here another term is there, so it is plus log x cos x. Yeah, so then send u to the right hand side. So what is u? What we assumed as u? U is our x cos x to the power x. So x cos x to the power x into the term, correct? This term. Yeah, I'll just remove this unwanted. So this is our du by dx. So now similarly you have to find dv by dx. So dv by dx. So what is v? X sin x to the power 1 by x. So x sin x to the power 1 by x. So this is equal to v. So apply log on both sides. Log v is equal to 1 by x log x into sin x. Correct. Next what we can do, differentiate on both sides. 1 by v dv by dx. Here let this be my first term, this be my second term. So first into differentiation of second. So first term 1 by x, let it be as it is. Differentiation of this, it will be 1 by second term is sin x. Then differentiation of this, what you have to do? Product rule. So according to product rule, first into differentiation of second, first into differentiation of second, it is cos x, plus second into differentiation of first, so sin x as it is, differentiation of x is 1, so sin x, plus second into differentiation of first, so log x sin x as it is, differentiation of first term 1 by x, it is minus 1 by x square. Correct. So now we have to simplify this. So here you can see 1 by x square is common. Correct. So we can add those two terms. But here what is missing? There is no sin x term, right? Okay, so let's try to solve it. Okay, let's try to simplify it. So what I'll do is 1 by x square, let it be common. Okay, that I will take it outside. So what is left here? Cos x plus sin x divided by sin x. So cos x by sin x is what? Cot x, right? So x is there, see, x cot x plus here sin by sin, it is 1, correct, plus 1, and here minus this term log x sin x. So I'm doing it directly. Okay, if you don't understand you can ask me, okay, don't hesitate. Then 1 by x square is there, right? So this term I will write it in the denominator. So x square. Now this is equal to, yeah, so now v is there, right? That will send to right hand side. So here in the place of v, what you have to write? V is sin x to the power cos x, right? Sin x to the power cos x. To the power cos x. So this is our dv by dx. So at the end what we have to do? We have to add these two terms, correct? So dy by dx is equal to this term yeah. So this term plus the another term, whatever we got it over here. Yeah. So this is our final answer. So yeah, is it right? So have I done any mistake? What is our v term? V term is x sin x to the power 1 by x. What I have written? X sin x to the power 1 by x. So this is not v. Nobody told me that. X sin x to the power 1 by x. Correct. V term is that, right? See, that's what we assumed. Yeah. When I taking it this side, I have to write that term. So I don't know why I wrote x sin x cos x and nobody told me anything. So here what is this? V term x sin x to the power 1 by x. One by x. Yeah. So you understood, right, how to do this? So if you want, you can verify your answer. So this is the answer what is given in the textbook. Yeah. So you understood, right, how to do this? So I'll continue. So now let's move to the next question. Yeah. Question number 12. Uh, Question number 12. How can we do? U plus V, right? So question number 12 is not that much difficult. So x to the power y plus y to the power x is equal to 1 is there. So how can we solve this? So consider this to be u, consider this to be v, and this is the constant. Okay, let it be as it is. So next step, what you can do? Find du by dx. Find dv by dx. That will be equal to this differentiation of constant 0. Correct. Then what you do? Solve this. Okay, when you solve this, you will get dy by dx term. Okay, then you take dy by dx common, then whatever remaining term you send it to right hand side. So if you solve it in that way, you'll get the answer. Okay, so I'll solve this kind of problem. So this kind of problem one we have solved in the exercise. Okay, no problem, I'll solve this. Yeah. So now this is u, this is v. So now du by dx plus dv by dx should give me equal to 0. And what is our question? We have to find dy by dx is how much? Correct. Dy by dx is how much? So what we can do? First find out du by dx. So what is u? U is equal to x to the power y, correct? So apply log on both sides. Log u is equal to y log x. Then what you can do? Differentiate on both sides. Differentiation of log u is 1 by u du by dx. And here differentiation of this product rule, first into differentiation of second. Differentiation of log x is plus second term into differentiation of first. Correct. Then next step what you can do, you send it to this side. So du by dx. So u x to the power y, x to the power y into y by x plus log x dy by dx. Okay, similarly solve for dv by dx. So what is v in this question? V is y to the power x, correct? So y to the power x. Now apply log on both sides. Then differentiation of log is 1 by v dv by dx. Here you have to apply product rule, first into differentiation of second. Differentiation of log y is 1 by y dy by dx, correct? Then plus second into differentiation of first. So second term is log y, differentiation of first, x is 1, so just log y, correct? Then next step what you can do is dv by dx is equal to, so v, what is v? V is y to the power x, right? Here, so here v, send it to this side. So y to the power x into this term. Correct. So now what you have to do? You have to substitute this equation. Correct. So the right hand side is 0. Just write those two terms and introduce 0 in the right hand side. So du by dx, it is x to the power y plus log x dy by dx plus, yeah, this term how can we write? Yeah, this term you have to write now, plus this term is equal to 0. Okay, so for what we want the answer? Dy by dx we want the answer. So what you have to do? You have to simplify this and try to bring in the form of dy by dx. So what is the procedure we can follow? So multiply this, open the bracket, so multiply this inside both. So here denominator there is x, correct? So when it goes to numerator, it will be the whatever power is there to the power minus 1, correct? So x to the power y minus 1 into y, correct? So when I multiplied this to the first term, when I multiply it to the second term, what will happen? it is x to the power y log x dy by dx. Similarly, you have to do for this. So what happens here? Law of exponents. That's it. So y is in the denominator. When it goes to the up, then what happens? Y to the power x minus 1. Correct. So plus y to the power x minus 1 into x dy by dx plus y to the power x log y to the power x log y, which is equal to 0. It is in the right hand side. Yeah. Next step, what we can do? You can send these two terms to the right hand side, which does not contain dy by dx. Correct. So which term contains dy by dx? These two term contains dy by dx. Correct. So dy by dx I will take constant. So dy by dx I took as common. Which is the coefficient term of it? It is x to the power y log x plus y to the power x minus 1 x. Correct. And what is the right hand side? These two we have to send it to right hand side. Correct. So minus of, so those both term are positive, so that's why I'm taking common minus. So x to the power y minus 1 into y plus y to the power x log y log y. Correct. So next, final answer, how can we write? So here this term is there, right? We'll send it to, I'll just zoom in a second. Yeah. So this term we'll send it to the denominator. Okay, no problem, I'll copy the whole. Okay, I have sent it to denominator. And this is our final answer. So just verify this answer whether it is correct. I will check it once. Yes, it's correct. Minus of yx to the power y minus 1 plus y log y. Yeah, yes, it's correct. So you understood, no, how to solve this? So this is little bit difficult, but not that much difficult. It's not like impossible, you can solve it, right? So you understood this, right? If you get problems of this type, how you have to solve? Do you have any doubts?
No, sir.
Alright, so let's take a short break now. Okay, so after 5 minutes we'll continue. Okay. Okay, then shall us continue?
Yes, sir.
Okay. So here, question number 13. I have uh, I have told you how to solve it, right? Last class I have solved it. So y to the power x is equal to x to the power x. This kind of problem. If you get this kind of x to the power y. So if you get this kind of problem, what approach you have to follow? Apply log on both sides. Correct. So question number 14 you check. Question number 14 is cos x to the power y is equal to cos y to the power x. Correct. This is also of similar type, right? So here also same approach you have to follow. Apply log on both sides. Then solve it. You will get the answer. Correct. So this is similar to this. Okay. So just solve it. Okay. So will you be able to do this? This is not that much difficult. Should I solve this? Or will you try?
No, we can try.
Okay. So question number 15 I will take now. So question number 15, x y is equal to e to the power x minus y. So now what you have to do is apply log on both sides. So here now see apply log on both sides is also okay. Yeah, so here you can solve it in two ways actually. You can do apply log on both sides, or you can directly differentiate this. So you know what is e to the power x differentiation. It will be e to the power x itself, right? So we'll try to solve it in both method now. Okay, and we'll check the answer. So here first, here what you have to do, product rule. So first function into differentiation of second. Differentiation of y is dy by dx plus second into differentiation of first y. Differentiation of first function is x. Correct. Differentiation of x is 1. And what is differentiation of e to the power x? It is e to the power x itself. Correct. But here in the place of x, what is there? X minus y. Then you have to go for differentiation of x minus y. What is differentiation of x minus y? Differentiation of x minus y is 1 minus dy by dx. Correct. Yeah. So next step what we can do, open the bracket, group dy by dx together, then take dy by dx common outside. Okay, so all this procedure we have to follow. So x dy by dx plus y, here e to the power x minus y, e to the power x minus y into 1 minus e to the power x minus y into dy by dx. Next step what we will do, send it to right hand side. Correct. So negative will become positive. So dy by dx I will take common outside. So x plus e to the power x minus y, and here y I will send to this side. So positive becomes negative. So e to the power x minus y minus y. Okay, so now I want dy by dx is how much, right? Dy by dx is equal to e to the power x minus y divided by e to the power x minus y plus x. So this is our answer if we don't apply log on both sides. Okay, I'll just check my answer. Question number 15, right? This is what I got. Okay, so if you don't apply log on both sides, this is the answer what you will get. Yeah, so it is different from the textbook answer. So for this problem, let's apply log on both sides, then we'll do. Yeah, so this answer is also not wrong. I don't know why it is not matching the question. Hmm. Anyways, let it be. So this whatever answer I got, it is not matching the textbook question. Yeah, textbook answer. Okay, no problem. So we'll do with applying log on both sides. We'll follow the same method. So when you apply log on both sides, what might happen? So log x plus log x into y is equal to, so x minus y will be power, right? Power will be multiple into log e. Okay, so now what is log e? So if you solve log e, what is the answer you are going to get?
So is it 1?
Yes, it is 1. So usually if you write log, it is base 10, but in your textbook it is assumed like log e is log means natural base e. Okay, so it is 1. So log xy is equal to x minus y. Okay, this term reduced to 1. Okay, now differentiate on both sides. So differentiation of log x, it is here what you can do is, either if you want you can expand it, log x plus log y. If you don't want to expand it, you can write it directly, no problem. Okay, so I will not expand it. Why? Because if you expand, you have to differentiate twice. Okay, differentiation of log x is 1 by x into differentiation of x into y. So what is differentiation of x? First in product rule, first into differentiation of second plus second into differentiation of first. So second term is y, differentiation of first is x. X is 1, that is equal to x minus yeah, so differentiation of x is how much? 1, correct. Differentiation of y is dy by dx. Yeah, next what we can do, just open this bracket. So when you open this bracket, what happens? X and x will cancel with this. So what you'll have, 1 by y dy by dx. Here what happens? Y and y will cancel and 1 by x will be remained, plus 1 by x 1 minus dy by dx. So next what you can do, take dy by dx term common. So dy by dx, if you take it common, so 1 by y, so this when it goes to this side, what happens? It will be positive, so plus 1. So there is no coefficient, so coefficient is 1, which is equal to 1 minus 1 by x. Okay, so next step what we can do, we'll try to simplify this. So here it will be, okay, I'll just take it to the other side, dy by dx. So here I can write it as x minus 1 divided by x, correct. This I have simplified. Here what I can do is, I'll just simplify this. So what happens here, 1 plus y, right? 1 plus y divided by y. So this divided by y, when I send it to numerator, so I can send it to numerator, correct. So this is my required answer. So you understood, no? How did I simplify this? So I have written directly, one step I have skipped. So I hope you have understood this. Okay, just solve this. Y denominator will be common, here x denominator will be common, then just take LCM, you'll get the answer. Then just simplify, take it to other side, you'll get the answer. Okay, this is how you solve. So here I don't know why this didn't work. It's e to the power, okay, let it be. Okay, so if you get the question in this type, you just do it in this method itself. Okay, applying log on both sides. Okay then, so let's solve now question number 16. So question number 16, how can you solve this? So you can see this question, f of x is equal to, there is 1 plus x, 1 plus x square, 1 plus x to the power 4 plus into 1 plus x to the power 8. So what is the easiest way to differentiate this? Just assume this f of x equal to y, okay? No need to write f of x. So what is the easiest way to this differentiate this? Apply log on both sides. What happens? This product will be converted into sums, correct? So log y will be equal to log of 1 plus x plus log of 1 plus x square, correct? So on. Then what you can do? Differentiate on both sides, correct? So this is not that much difficult. So can you solve it? This is not that much difficult problem. Just use the definite properties of log. Log a into b into c you can write as log a plus log b plus log c, correct? So question number 16, it is not that much difficult. So you try it, okay? So once you get the answer, so once you get dy by dx, okay, that is equal to f dash of x, then what you do? Whatever expression you got, right? For that you just substitute the value x equal to 1. Okay, so whatever answer you get, it is f dash of 1. Understood? So I hope it is not that much difficult. I hope it is not that much difficult. So can you solve it on your own?
Yeah, sir.
Okay then. So let's. So I wanted to start a new topic. Okay, we'll see how many questions are left. Okay, so question number 17. Question number 17, they have given differentiate x square minus 5x plus 8 into x cube plus 7x plus 9 in the below mentioned way. So see, first one you know we have done it previously using product rule. So how can you solve it? So the question is x square minus 5x plus 8 to x cube plus 7x plus 9. So assume this to be your first function, this to be a second function. Then apply product rule. First function into differentiation of second plus second into differentiation of first. Okay. So by that method you can solve. And they have said second method. Second method, what you have to do? You have to literally multiply. First you have to expand this bracket. Okay. And then you apply differentiation. Okay. So even that is also easy. And third method, applying log on both sides, logarithmic differentiation. Even that is easier. So what happens? It converts into sums, correct? Sums of log. Correct. So this is also easy. So question number 17, I don't feel it is difficult. Okay, so when you differentiate in this all these three method, you have to get the same answer back. Okay, so if you are getting same answer, then your answer is correct. So question number 17, I will leave it to you. Okay, so let's see question number 18. Question number 18, see, you have to just see here, you know the product rule for two variables, right? What if you have three variables? How can you write? So see, there are two ways to derive this. One, you can use product rule, repeated product rule, or else using logarithmic differentiation also you can do this. Okay, so here first I will say how to do with normal differentiation. So using product rule, how can you solve? It is function of, you have three variables here. Okay, so how will you differentiate? With respect to x, you have to differentiate. So first what you consider is this two, let it be your second function, this let it be your first function. So according to product rule, how can you solve this? First into differentiation of second, v into w, plus second into differentiation of first. Second is differentiation of first is du by dx. Correct. Then expand this, u as it is, differentiation of this, again product rule. So here if you apply product rule for this, what happens? First into differentiation of second plus second into differentiation of first. So second term is w dv by dx. Correct. Then what you can do is the third term as it is, du by dx. Then next what you do? Open the bracket. So when you open the bracket, it gets multiplied with the both term. Correct. So u into v, then here uw. Okay, this is your required proof. This is one way of deriving it. Okay, so there is another way. What is the another way? You can do like this. Consider y is equal to u into v into w. Next step what you can do? Apply log on both sides. Log y is equal to log, see what happens, log u into v into w. Correct. So product you can write it as sum of log. Correct. So log y, so u log u plus log v plus log w. Correct. Then differentiate on both sides. So when you differentiate 1 by y dy by dx. Yeah. Log u, what is the differentiation of log u? 1 by du by dx. Correct. Plus 1 by v dv by dx. Plus 1 by w dw by dx. Okay, dw by dx. Next step what you have to do? Send y to the right hand side. So what is y? Y is u into v into w, right? dy by dx. Yeah, so multiply, send it to other side. So what happens? It multiplies. So u into v into w dy by dx divided by u. Correct. Plus it gets multiplied with all the terms. Correct. So here you can see u and u will cancel. Correct. So similarly here also v and v will cancel. What will be left? u and w, correct, dv by dx. So here also w and w will cancel, correct, u and v are left, plus u v dw by dx. So this is the other way to prove the same. Understood? So these kind of questions are very rarely asked, okay? They will not ask you to prove and all. But it is important. Like, you have to know how to prove. If somebody asks you, you have to know how to answer. So have you understood this? You have understood, right? Yeah. So
Yeah, sir.
so let's move to the next new concept, okay? So now our new concept is parametric form. Okay, differentiation of function in parametric form. So you have to understand what is parametric. Parametric form. So see, you have studied what is explicit function, what is implicit function, correct? In the similar way, imagine usually how we write y is equal to f of x, correct? So for example, y is equal to x square plus 3 plus 3x plus 1, right? So here x is called independent variable, y is called dependent variable, correct? So here sometimes what happens is, here y is related in terms of x, correct, but there are certain kind of equation where here it is only two variables, right? But there are certain kind of this variables equation where these both term will be related to the third variable. So consider it to be f of t. Okay, so usually what expression we see, we see y is equal to f of x, these kind of equation, correct? So there are some kind of equation where y is written as variable of some another parameter, some another variable, and x is also written as a function of some another variable. Okay, these kind of forms are called parametric form. Okay, and process of converting this, so process of making it normal equation 2 into parametric form, it is called parametrization. Okay, so just understand this much. So what happens is, usually we write y in terms of x, correct? So parametric equation are such kind of equation where there is third variable called parameter. Okay, third variable, there will be third variable, and this variable is known as parameter. Okay, usually we take it as t. Okay, so our equation will be relating in this way: x is equal to f of t and y is equal to g of t. Okay, the equation will be in this way. Okay, so such kind of equation you have to know how to derive. Okay, so usually there is one easier formula. Okay, so what you do is, if you want to find dy by dx, okay, the procedure is simple: differentiate y with respect to t, differentiate y with respect to t, and differentiate x with respect to t. Okay, then divide these both, you'll get your answer, dy by dx. Okay, this is the procedure what you have to follow: differentiate your y equation with respect to t, differentiate your x equation with respect to t, and divide it, you will get your answer. Okay, simple as it. Okay, now the question arises, why it is important? Okay, so see, if you know this logic you can just solve it. Okay, but if you don't know what is the importance of parametric equation, there's no use of solving it. Even though you know to solve it, it is not much significant from your side. Okay, so let's understand what is the importance. Even though it is not there in your syllabus, they won't ask you in exam. Okay, so I'll just tell you what is the importance. I feel it is important that you should know. Yeah, so now imagine what happens here. So you know how, so here imagine you are on the earth, okay, you are on the surface of earth. So do you know how does this if I want anywhere from the earth, if I want to locate you, what are the three parameters I need? So you have used Google Maps, right? So in Google Maps you just enter your location and you will get it, correct? So here you will get something known as coordinates, correct? And these coordinates are made up of three components, correct? So if I want to locate you anywhere from the earth, okay, what should I do? I have first three things I have to know. First thing is longitude, correct? I have to know what is the longitude, correct? I have to know what is the latitude, correct? And I have to know what is the altitude, correct? So imagine if you are on the ground, so if I know these two properties I can locate you. What if you are in some flat, okay, so you are above from the ground, right? In that time what I need to know, I need to know altitude to locate you accurately, correct? So see, these are actually the parameters, whatever you see this, right? So all satellites, Google Map works on this principle: longitude, latitude and altitude. So you know this earth, right? Earth, so there are some horizontal, if you see the map, world map, there are some vertical lines, there are some horizontal line. These are longitude and latitude, correct? And there is something called as altitude. Altitude is like height from the ground, how much height you are, correct? These three are the parameter, okay? So see, if you want see a sphere, if I consider earth to be a sphere, so do you know equation of sphere? How does a sphere look like if I want to write it in terms of x, y, z? Okay, so the equation of sphere looks like this. So x square plus y square plus z square. So if my square is of 3 centimeter, see here, this is square of 3 centimeter radius. So I can just do like this. You can see here 3 centimeter. 2, it is between 2 and 4, right? So these are my, this is my sphere, correct? If I want to locate you somewhere around this, I have to know three parameter. What is the longitude? What is the altitude? What is the longitude, correct? So these three parameters I have to know. So see, if I want to calculate this using my normal method, what happens? It will become more difficult. Why? Because these are not our 2D thing, these are our 3D things, correct? So in this case what happens? Parametrization is very useful. So x coordinate is written, so these all things you cannot need not know. So here you do the parametrization in terms of angle. So one, you have to know what is the radius of this, then what you do is you mention two kind of angles, okay, and you do the equation. Okay, this is one of the application. Okay, and sometimes when you come to integration and all, it will be easier. So if you want to find out area of the circle, if you want to find out area of certain things, okay, if you use your normal method, what happens? It becomes difficult. Okay, when you use parametrization, what happens? The problem will reduce to a simple problem. Okay, so those are the application of it. So I hope you understood. So here, see, circle. So do you know the equation for circle in conic section? Have you studied it? Equation of circle.
Yes, sir. Last year, right?
Yeah, last year. So how it is? If I have radius 3 centimeter, how can I write equation of a circle? It is x square plus y square is equal to 9, correct? Generally equation of circle is like this, right? X square plus y square is equal to r square if my center is at origin, correct? H comma k.
Yes, sir.
So see, this, if you find area of the circle, you can find the area of the circle if you know the radius, correct? So how do you find pi r square? Correct. So here the same problem can be solved using parametric equation. So here what I can do is, wherever x is there, no, I can substitute x is equal to 3 cos theta and y is equal to 3 sin theta. Okay. So see, if I substitute this, now see, here I have two variables, right? Here what I have to do, here I have two variables. So if I substitute this now, what happens? My problem is reduced to only one variable. So this is the advantage. So now see, if I substitute this, so in the process of parametrization, you have to select the equation in such a way that when you substitute this, it will not make any difference to the question. Okay, so just substitute and solve it. You'll get 9 as your answer. So what happens is 3 square cos square. Here it will be 3 square cos square plus 3 square sin square is equal to 9. So now 3 square is 9. 9 take it common outside. So cos square plus sin square is equal to 1. So 9 equal to 9. So our question is not alterated. So this is the advantage of the parametrization. So if I want to visualize it, I can just show you. So equation of circle, x square plus y square is equal to 9. See here, radius 3, correct? You can see radius 3 if I zoom in, correct? 3 minus 3 to 3. So this is one method. So if I have x and y coordinate, I can write it. What if I want to write in terms of this parameter? So x is equal to, I can write like this, 3 cos t. Okay, so one I will write it as like this. I missed something. So let it be 3 so 3 cos t and let it be 3 sin t. X is equal to, yeah, so it should be reversed actually. X is cos, y is sin. Yeah, so now just observe this, observe these two speed. Yeah, so just observe these two. You can see here what happens here. How is the arrow mark moving from 3 to 3, correct? How it is, what is the form it is tracing? It is tracing a circle, right? The point intersecting, look at that, focus on that. What you can see there, what is it forming? It is forming a circle, right? And what is the radius of it? It is from 3 to 3, correct? If I just zoom in, yeah, so the point will reach 3 now, see, minus 3 after some time, correct? So this is the power of this is the parametrization. So see, the same equation I have represented in terms of some other parameter. You can see, right? Yeah, so here the problem of two variable has been reduced to one variable. Okay, this is the advantage of it. So you need not know this much deeply and all what is parametrization. So just understand the procedure, how you have to do. So first thing what you have to do, whichever other parameter you have, so you will have the expression in this way. They will give you the expression in this way. X is equal to some function of t, y is equal to some function of t. What you have to do? They will ask you to find out dy by dx. So what you have to do? Dy by dx you find out. So dy by dx, how will you find out? First, dy by dt you do. then dx by dt you do. Then what you do, you just divide these two. Okay, that will be your differentiation. So you understood this procedure, right? So let's solve some exercise. Let's solve some problem. So now d, so I'll take example. Okay, so let's take one example. So if x is equal to a cos theta and if y is equal to a sin theta, so what is dy by dx? So first step, what you have to do, differentiate with respect to t, differentiate x with respect to theta. So now what is the parameter? Theta. Theta is a parameter now. Okay, so find dx by dt. So what is dx by d theta? A cos theta. Cos theta's differentiation is,
minus sin theta.
yes, a is constant, so minus a sin theta. And what is differentiation of dy by d theta? It is a cos theta, correct? So next step, what you have to do, dy by dx, so dy by dx is equal to, yeah, so dy by d theta divided by dx by d theta, dy by d theta divided by dx by d theta. So what I got, dy by d theta, it is a cos theta. What is dx by d theta? It is minus a sin theta, correct? So a will cancel, cos theta by sin theta is cot theta, then there is a minus sign, so minus cot theta is your answer. Okay, this is how you solve. The procedure is simple. Identify the parameter, differentiate y with respect to that parameter, differentiation x with respect to that parameter, then dy by d theta divided by dx by d theta. Okay, so if you do that, that is your answer. So you understood this, right? So I'll take another example. So the example is, let us take x is equal to 80 square, y is equal to 280. Okay, so this is one kind of this parameterization. Yeah, so now they are asked, they have given x and y, they are asking me to find dy by dx, differentiation of y with respect to x. So how can I find this? So first find out dy, identify the parameter. So now parameter is what? T is the parameter, a is a constant. Okay, so next step, what you have to do, find out dy by dt. So dy by dt, what is here? 280. Differentiation of 280 is 2a. Okay, then next step, what you find? dy dx by dt. So if I find dx by dt, what is the answer? It is 2at, correct? T square, differentiation of 2 t square is 2t, correct? A is constant, 2at, correct? I found out this also. Next step, what you have to do, dy by dx, correct? Dy by dx is equal to dy by dt divided by dx by dt, correct? So that is equal to, what is dy by dt? It is 2a divided by 2a into t. So 2a will cancel, 1 by t is left. Okay, this is how you find the answer. Yeah, So you understood this, right?
Yes, sir.
So this section is easy, not that much difficult. Okay, so let's take another example. So x is equal to a theta plus sine theta, and y is equal to a into 1 minus cos theta. Yeah. So how can you solve this? First find out dy by dt. So identify the parameter. So here what is the parameter? Theta is the parameter. Okay, next step what you have to do? Differentiate with respect to that parameter. So first let's find out what is dy by dt.
Sir,
Yeah.
which question is this?
This is from the example question. Example
Okay.
36. Okay. So these are already solved. So I'm just giving you just example. So if you want I can just so if you can understand those example I'll just move to the problem. Is it fine? Like should I do the example? Okay, so I'll just do this problem, then we'll move to the exercise. Yeah, so these are not that much difficult actually. So how can you now differentiate with respect to theta? So y, what happens with respect to theta? Dy by d theta. So a is constant, 1 is constant. So what I'll do is I can multiply this. So when I multiply, what happens? A minus a cos theta, correct? So differentiation of a constant is 0 minus differentiation of cos theta, it is minus sin theta, correct? A into minus sin theta, correct? So this minus and minus will become positive. So a sin theta, and you can do dx by d theta also, dx by d theta. So if you do dx by d theta, so what is the answer here? A into theta, so a theta, differentiation of a theta is a. Then a into sin theta, differentiation of sin theta is cos theta, so a cos theta. So we have got what is dx by d theta and dy by d theta, correct? So dy by dx is equal to dy by d theta divided by dx by d theta, correct? Dy by d theta is a sin theta. Then here it will be a plus a cos theta, correct? So then later what we can do? We can a is common, right? So a we can cancel. So remove a common out and then cancel. So what will remain? It will be sin theta divided by 1 plus cos theta. So if you leave your answer to till here, it's more than enough. Okay, so if in case if you want to solve it, you can solve it. So what is the way you can solve it? So you have to use half angle formula. So sin theta can be solved as 2 sin theta by 2 by cos theta by 2. Okay, so 1 plus cos theta, how can you write? So you can use cos 2 theta formula, right? So cos theta is equal to cos square x minus sin square x, right? So here cos square theta by 2 minus sin square theta by 2. But here what I have to do is I want to keep it in such a form that I can cancel this. So I want 1 plus cos theta. So what I will do is I will just modify this. So here it will be this formula, right? So minus 1 I will send it to that side. So what happens? It is here 1 plus cos theta. So 1 plus cos theta is 2 cos square theta by 2. Cos square theta by 2. Okay, then here what can I do is 1 I can cancel, 2 this I can cancel. So sin theta by 2 by cos theta by 2 is tan theta by 2. So that's what it is given in your textbook, correct? Tan theta by 2. So see, in case if you get this answer, if you don't know to solve, don't solve. Okay, understood, right? So if you got the correct answer, don't go to solve it. Okay, so if you are very sure, then only you solve it. Why? Because if you write wrong answer later, what happens? Your marks will be deducted. They won't consider this. Whatever final answer you have written, no, that they will consider. Okay, it's better to be safe. Okay, if you don't know to solve trigonometry, no problem. Leave it to that stage. No issues. Yeah. So see, we'll take another example. So x to the power 2 by 3 plus y to the power 2 by 3 is equal to a to the power 2 by 3. Yeah, this problem, how can you solve? So there are two methods to solve it. One is implicit differentiation, another one is parametrization. Okay, so if they give you in this way, it is better to solve in implicit differentiation. Okay, if you do it in implicit differentiation, you will get your answer easily. Okay, if you want, you can use parametrization. Yeah. So here in the textbook they have used parametrization. So what I'll do is I'll first do with the implicit differentiation. So here differentiation of 2x to differentiate on both sides. So what is differentiation of x to the power 2 by 3? It is nx to the power n minus 1 formula, right? 2 by 3 minus 1. So what is 2 by 3 minus 1 if I solve it? So 2 minus 3 divided by 3, it is minus 1 by 3. So here instead of this, I can write minus 1 by 3 plus what is differentiation of y to the power 2 by 3? It is again the same, 2 by 3 y to the power minus 1 by 3, but here there is y term, that's why dy by dx. Now however this, you see this is a, correct? A is a constant term, so differentiation of constant is 0, correct? So what answer we want? We want dy by dx is how much, right? So now what I can do is 2 by 3 I can take it common outside, correct? 2 by 3 I can take common outside. So 2 by 3 I have taken common outside. Then see 2 by 3, if I send it to right hand side, 0 0 into 3 divided by 2, it will be 0, so it will be reduced, correct? So now what is left? Dy by dx is equal to, here I'll send it to other side, so that will be minus x to the power 1 by 3. So if I want, I can send it to denominator this, correct? So it will be 1 by x to the power 1 by 3, correct? Now here y to the power 1 by 3, so if I send it to another side, what happens? This term will be in the denominator, correct? Y to the power minus 1 by 3. So if I want this power in terms of positive, what I have to do? I have to send it to numerator. So what happens? It will be y to the power 1 by 3. So to the power 1 by 3, it means it is cube root of, correct? So this I can just write it as minus cube root of y by x. Okay, so this is the one way you can solve using implicit differentiation. See, if you use implicit differentiation, the problem will be easier. See, just within 2 steps I have solved. Okay, I have stepped in between some steps, but still it is not that much lengthier, correct? The same you can do using parametrization, but see, using parametrization you have to be careful. You have to choose x and y in such a way that it does not alterates the equation, correct? So what is the possible value you can choose for x and y? It shouldn't alter this equation. So see, if you have any way like this x square and y square term, okay, the simple thing what you have to do is, so I will just give you one example. I have give you an example of a circle, correct? X square plus y square is equal to 9. Okay, so what is the parameterization for this? Suitable parameterization is x you have to choose. Say this is equal to 3 square, equation of circle. The suitable parameterization what you have to do is, this number is there, right? This number into cos theta. X is always written in terms of cos, okay, and y is always written in terms of sine, and you know the reason why it is. This is the suitable parameterization. If I substitute this, this will not alter. Okay, here in this case there is 2 by 3 here, correct? In this case,
Sir,
yeah,
I didn't get why you took cos and sine.
yeah, so I'll tell you why it is. So if this is my y axis and this is my x axis, okay, if I just draw a line here, okay, so if this is my theta, yeah, so this is my x distance, this is my y distance, correct? So now opposite side you write it as, so if this is my a, okay, distance, so this, if I want to write the equation for y in terms of theta, how can I write? Y is equal to, this is opposite sign, right? Y is equal to a sine theta. I can write it like that, right? In physics and all you might have
Yes, sir.
used it. And x is adjacent side. Adjacent side is always written in terms of cos theta. Correct? I can write it like this, right? So this is what parameterization means. So yeah. So that's why it is cos theta and sin theta. You understood this, right?
Yes, sir.
Yeah, okay. So here parameterization how you will apply. So if you take cos theta and sin theta, it won't work. Why? Because the power is this 2 by 3. So here what you have to do is, you have to try to bring cos square term, you want to bring sin square term, but when you add those two terms, what should happen? It should become 1. But here already 2 by 3 is there. So what you have to do? You just do one thing, you take cube term. Okay. So when you take cube term, what happens? So if I take for x, if I take like this, a cos theta whole cube if I take, okay, so when I substitute to this equation, what happens? 3 3 will cancel and I will get cos square, correct? And similarly if I do for sine, I will get sine square, correct? And a square a to the power 2 by 3 a to the power 2 by 3 will be common, correct? So if I substitute those, this will reduce to 1. So see, the our original equation is not affected, correct? Understood? So during parameterization, you have to carefully choose the expression in terms of third variable in such a way that it does not affect our original equation. Okay, so yeah, so here in your PU you won't use it much, okay, but when you go to higher studies, you might have to, if you take engineering or if you take BSc, MSc, okay, you have to use it regularly, parameterization and all. Okay, so this is only one example problem, there are no other problem like this. Okay, yeah, so x, what you have to choose? X is equal to, what is the this radius here? It is a to the power 2 by 3. So just choose a cos cube theta. Okay, this is my suitable parameterization, correct? And y is equal to a sine cube theta. So see, for a, why I haven't choose any powers? Why? Because when I substitute for this, my a shouldn't alter it, correct? The right hand side I should get the same. So let's substitute to the equation. So in place of x, what I have to substitute? A cos cube theta to the power 2 by 3, a 2 by 3 is equal to, so if I solve this, what answer I would get? So here a to the power 2 by 3 into here cos See, 3 will cancel, cos square theta plus a to the power 2 by 3. Here 3 will cancel, then sin square theta. Okay, so here a to the power 2 by 3 is common, right? So cos square theta plus sin square theta, which is equal to 1. Correct. So 1 into 2 by 3 is 2 by 3. So that is our right hand side. Correct. So in this way you have to choose the parametrization. Yeah, so it is not altering our original equation. Then what you do, you know the procedure. Dx by d theta, dy by d theta, and just find out dy by dx by dividing these both. Okay, just divided by this. So this is the procedure. So I hope you understood how to solve. You got the general idea about parametric equation and all. Okay, so in next class, see, in next class I won't be taking the class. Okay, Misty ma'am will be taking the class. Okay, and she will continue with the topic. Okay, so do you have any doubts?
No, sir.
Okay, okay then, so you can leave the class.
Thank you, sir.
Yeah,
Thank you, sir.
yeah, welcome. Hello ma'am.
Hello, sir. Good evening.
Good evening, sir. Good evening, ma'am. Sorry. Like, ma'am, you don't need to do all exercises. Just whichever you find it difficult, you solve those exercises and ask the students whether they are finding those particular question difficult. Whether if they can solve by themselves, just leave it to them, ma'am. Just give it as a homework. They will
Okay.
solve and send it to you. You then correct it and
So,
send it.
sir,
Yeah.
any numerical worksheet is also have to provide, like for a week.
Nothing like that. Whichever you in while updating, so each day you have to update whatever class you did. Then with that you just mention which exercise number and what problem you have given as your homework.
Okay, so sir, you just for only did that NCRT questions now with the beside NCRT any other questions?
No. I haven't done any other questions. Only NCRT.
No need na.
No need.
Okay, okay, sir.
Okay. Okay then. All the best.
Thank you, sir.
Okay. Okay then I'll leave the class.
Yes, sir. Sure.